The moon. Our celestial companion, a familiar face in the night sky, gone. Imagine looking up one night to find its gentle glow replaced by an empty void. No more silvery light illuminating the darkness, no more lunar phases to mark the passage of time. The sudden absence of the moon would be more than an astronomical oddity. It would be a profound and unsettling event, a cosmic vanishing act with far-reaching consequences for life on Earth. This isn't a scene from science fiction. This is a thought experiment, a glimpse into a world stripped of its lunar anchor. A world plunged into darkness far beyond the absence of moonlight. A world grappling with the fundamental laws of physics, suddenly rewritten. Hold that image in your mind. The vast emptiness where the moon once shone. This is where our journey begins. A journey into a world forever altered by the loss of its celestial companion. A journey to understand the intricate dance between Earth and Moon, a dance we often take for granted until the music stops. The most immediate consequence of the moon's disappearance would be, of course, the darkness. No more romantic moonlit walks, no more nocturnal creatures relying on its soft glow for navigation. The night sky, once punctuated by the moon's reassuring presence, would become an expanse of unrelenting black, save for the distant twinkle of stars. This sudden plunge into perpetual night would have immediate and dramatic consequences for the natural world. Nocturnal animals, their evolutionary paths intertwined with the lunar cycle, would find themselves thrust into disarray. Predators accustomed to hunting under the cover of moonlight would struggle to adapt, while prey animals would lose their nocturnal advantage. But the impact extends far beyond the animal kingdom. Humans too have evolved under the moon's watchful gaze. Our sleep-wake cycles, our very perception of time, are subtly influenced by the lunar cycle. The sudden absence of this celestial timekeeper would disrupt our internal rhythms, potentially leading to widespread sleep disturbances, mood swings, and other psychological effects. The disappearance of the moon would be a stark reminder of our place in the cosmic order, a humbling testament to the interconnectedness of the universe. A reminder that even the seemingly permanent can vanish in an instant, leaving us to grapple with the consequences. The moon's influence extends far beyond illuminating our night sky. Its gravitational pull is the primary driver of Earth's tides, the rhythmic rise and fall of ocean levels that shape coastlines and marine ecosystems. Without the moon, the oceans would experience a dramatic shift. The most noticeable change would be a drastic reduction in tidal range. No longer subject to the moon's gravitational tug, tides would be driven solely by the sun's weaker influence. This would result in much smaller tidal ranges, perhaps as little as 1/3 of what we're accustomed to. The consequences for marine life would be profound. Intertidal zones, those bustling ecosystems teeming with life exposed at low tide and submerged at high tide, would shrink dramatically. Organisms adapted to the regular cycle of submersion and exposure would face an existential crisis. Food chains would collapse as species struggle to adapt to the new, less dynamic environment. But the impact wouldn't be limited to coastal regions. The ocean's currents, driven in part by tidal forces, would also be disrupted. This could lead to changes in global weather patterns as the ocean's role in heat distribution is thrown off balance. The disappearance of the moon would be like pulling a thread from the tapestry of life, unraveling the delicate balance of Earth's ecosystems. Beyond the immediate effects on night tides and life, the moon's absence would have profound long-term consequences for Earth's stability and climate. Our planet, you see, isn't perfectly upright in its orbit around the sun. It's tilted on its axis at about 23.5 degrees. This tilt, responsible for our seasons, is stabilized by the moon's gravitational influence. Without the moon acting as a gravitational counterbalance, Earth's axial tilt would become vulnerable to the gravitational tugs of other planets in our solar system, particularly Jupiter. Over thousands of years, this could cause the Earth's tilt to wobble dramatically, shifting between extremes. Imagine seasons so extreme that they swing from scorching summers to frigid winters within a matter of months. Imagine regions experiencing near-permanent daylight for part of the year. plunged into months of darkness for the rest. This kind of climatic instability would wreak havoc on ecosystems, making it nearly impossible for many species, including our own, to survive. The moon, often seen as a passive celestial body, plays a crucial role in maintaining the delicate balance that makes life on Earth possible. Its absence would leave our planet vulnerable to forces beyond our control, transforming our world into a far less hospitable place.